to see such a huge turnout. I think it's at least more than double of what we had in Seattle, so that's very exciting. And so just real quick, my name is Erin Boyd. I will work at Red Hat. I've been involved since the inception of the PVC in Kubernetes. So I appreciate being asked to be the moderator and excited to hear everyone's opinions because I think they're kind of varied on this panel. So let's get started. So just to start off, what are the challenges of container-based storage over traditional vendor offerings? Who wants to start?
Well,
Jeff?
is it on? People hear me? Or?
Maybe.
Yep. The light's on.
The light's on.
The light's on. Here.
Yeah, there you go.
So I think one of the most important aspects is locus of control. So who is of control the PVCs and the PVs and whatnot, and how can the developer decide what happens on the system? Because storage systems traditionally have these backup schedules and all these type of things, and you don't want to get into the situation where you basically start to rumble with your storage administrator about when you're running your CI/CD, because you shouldn't be doing that when he is doing his backup schedule or something like that, because you back up the artifact. So these are like very small things straight off the bat that would help if you use cloud native storage, because the developer is more in control and can decide more about what is happening, when, how the data needs to be laid out, what needs to be replicated and whatnot. So I think that that's one of the low-hanging fruits.
Does this one work? This one works. So I agree with everything Jeffrey says. I'll add a different point of view, and that's portability. I think portability becomes super important when we talk about robustness and how applications need to move and access their data. So I think that's very different than the traditional three-tier model that we're used to, especially in monolithic applications. So what we see a lot of times is that there needs to be a way to centrally manage as well as control, but then at the same time it becomes, how do I make a portable, just like Jared was talking about earlier, how do I make a portable data layer?
So just in terms of introduction, Niraj Tolia, co-founder at Kasten, been working on storage systems since 2002 right now, and going to take a slightly different point of view here where when people talk about storage, I think storage is essential for the cloud native environment we are in. But when we go look at cloud native storage, those two terms being associated together, want to figure out, it wasn't me. Want to figure out, right, as a part of this panel, what does that really mean for us? Do we really need a brand new storage stack in there? The answer might be yes, no, or maybe. Hopefully we'll get to some answer. And how do you provide customers choice and ultimately what they want? So I think there's definitely a growing need for storage as more applications are moving into this as Kubernetes is taking off. But do we really need cloud native storage? Let's figure that out today.
That's a perfect lead into my next question, because what do you feel like as a community, what steps are we taking to help with the automation and governance, since it is so varied, you know, your opinions of whether or not we actually need cloud native or we need a layer on top of it? Do you want to start?
Sure. So I think automation, governance, et cetera, are definitely first-class citizens in this environment, right? Where whether you look at it from the point of view of the top-level APIs operators use, the users, the developers might use, having APIs such as CSI, having APIs, as some of the things that's happening as a part of GKE Anthos, et cetera, that make lives easier is really important. Having RBAC come in from the user perspective is really important. But then how they get translated underneath, right, Erin, is what Red Hat itself is trying to do with OCS, and whether this becomes a part of Gluster, Ceph, et cetera, underneath the hood, or some of the newer systems out there, I think is somewhat secondary. What's important is we service the people sitting above the storage layer with these APIs.
Yep, I agree. Jeff, do you want, oh, here, go ahead.
Yeah, I would agree with that for sure. The good abstractions for creating PVs and PVCs and the likes through CSI make it possible for the developer to at least express the intent of what the volume should do. So, for example, in terms of data placement, you can have these filters in terms of where you want the data to be placed, or at least on what node. But it's not necessarily the physical data that you control at that level. So that is something still that I think is worth of improving.
So I think some things that Luis Pabon back there has done with CSI has been super important, working with the ecosystem. And I think it's everything that these two guys are saying, but at the same time, for me, it's also about the life cycle in terms of the time. So obviously there's a create, there's importance about how we do it securely, but then there's also things that happen afterwards. So we can't have everything go through the CO, right? And this is something that others have talked to me about, and as we talk in the ecosystem, it seems very important that we centralize everything using something like a Kubernetes system, which is, I think, the best way to do it. But there's also things that happen after the data lifecycle, right? So we've found that when we get to zero trust environments, there still is a need for other ways to, in some ways, have a unified control, but at the same time understand how we can move data through its lifecycle and not only depend on one system in some ways. So I think automation is straightforward, or automation is becoming better when it comes to the creation and the deletion of objects, but when it comes to the lifecycle and how we move data throughout, it's becoming actually in some ways not answered yet.
Is it working now? Okay. All right, so given that the governance and the life cycle and all that is still pretty immature, what do you feel like, what considerations should be taken into account with customers when they're looking at like a multi-cloud or hybrid cloud configuration in terms of storage?
I'll just start in the sense of going in reverse.
Yep.
If that's okay.
That
I think multi-cloud is actually in some ways, I was talking to an imaging customer of ours, and I was asking them why they're going multi-cloud. And from their perspective, it becomes that they have different tenants, right? So intelligence agencies, et cetera. So they can't always assume that one cloud is sufficient, especially when you go multinational. So I think multi-cloud, I used to think is kind of some cute buzzword, but it's turning out more and more that it's actually the basis for a lot of important decisions. And I think actually that the one thing that we haven't done well in this ecosystem per se, if I look at networking's done a great job of explaining why CNI, and I know that everything we're doing is really critical and important, but I don't think we've explained the need well enough. And for multi-cloud to truly take off, data is actually the last thing to actually make it work. And so I think we're still in a world where, and this is having been in this ecosystem for a while, something I hope we do better, and I'm excited about today, is that I hope we're doing better of educating to users why data is central, data is part of multi-cloud, and it needs to be part of their strategy. And this whole idea of stateless doesn't really exist. So this is where I think multi-cloud is important. I think data is the key element. And I think from the perspective to make sure I answer your question, Erin, is that I think multi-cloud, for it to take the next step, we haven't demonstrated to users how simple and how central it is. And I think it's conceptually true for all of us who use it, but it's harder for those who are the ones that are, at the end of the day, operating in their production environments. And we have to explain that better.
Yeah, so one of the probably, perhaps maybe more technical aspects of it is that you need to look out for when you talk about multi-cloud is that you don't, see if you enter a public cloud, it's like a candy shop. You have all these services and all these things that you can do, and they handle it for you, and you don't have to worry about anything. So in terms of data, let's say, encryption is one of these aspects, right? But what do you do when you want to move from one cloud to the other and you have encrypted data? How does that work, right? So these things are becoming a problem, and then you might want to say, well, maybe multi-cloud is not all that important, but at least I want to be sure that I'm not locked in, right? I think that that's probably a more realistic goal than doing multi-cloud per se, because everybody talks about it, nobody actually does it yet for reasons that he mentioned, but yeah, I think the thing that you need to watch out for is that you don't lock yourself into a particular cloud vendor, but look for like a more common abstraction at the control plane level that allows you to, express the intent, what you actually want to have happen.
So I'm not going to take up too much time because I would just echo what people said, but I would like to stress upon the API perspective, and that for users, developers to think carefully about architecting for this. And whether it be using things like cross-plane that was just talked about a few minutes ago, or making sure that you can use the best of breed technology no matter what environment you're in, will give you a lot of power. I think Kubernetes is going to be the vehicle to do that. It's available everywhere today. It will allow you to write once and pretty much deploy anywhere, but you're going to need to spend a little bit more time thinking about the stateful components and how you're going to port those over, move those over.
Right. And so I like what you said, Eric, about there's no such thing as stateless, especially when it comes to data. And I think that was one of our primary challenges when we started Kubernetes, that, they were surprised that we wanted to talk about storage, right? It was just assumed you would use whatever's in the cloud and your data would be there.
This is a lot harder.
Yes, it is hard. And certainly for hybrid cloud storage is probably one of the hardest challenges we have. So with that, what do you feel like is the next challenge for storage in Kubernetes?
That's a good question, and I've been thinking about it for a while because you did help prep us. I think, I do think it's about that ease of use, right? I think everyone understands how to do a demo and does a hello world style PVC create. I think the challenge is really going to be about how we do migration, if you will. I think migration is, in some ways, I still think that there's a move towards, and this is a little bit outside of just storage, I think there's a move towards immutable infrastructure. That's what I'd like to see things go towards. I think it helps people run in production much better, and I think storage has been the thing that's held them back, if you will. So if we can get to the point where migration is seamless, I think that would really turn on people's understanding of what they can do. And I think that, if we could tackle that as an ecosystem in Kubernetes, that would make it really powerful for both multi-cloud and production. So I'm just enamored with the idea of immutable and migration being the way to get there.
Yeah, and I would agree with that. Data movability is probably one of the most important aspects, but one of the things that you should look out for in your storage solution, whichever it is that it does so securely, right? So thinking about diff things and things like that. So because if you move, I don't know, 100 gigs from one cloud to the other, how do you ensure that the data you moved is actually the data that you wanted to move? So there's that. Then the other aspect is not so much what I see, at least. Been talking to a large construction company very recently, and they would like to go to the cloud, but they still have this legacy infrastructure that they have there for a long time, and it's not written off anytime soon. So how do I get my data without going down into these cloud-native environments? And it kind of amounts to the same problem, right? So you need to be able to consume existing storage and then transparently move it into the cloud. And we have some interesting ideas around that, or at least I think, because I've been trying to work on them for sure. But yeah, I think that those things are probably the most important, such that you can reason about your data and not so much just say I need 10 gigs, but actually be more specific on what you actually want and where you want it to be.
So in my point of view, the future of storage in this environment is not about how you store the bits. I think a lot of us know how to do that very well. It's about how we're going to make it a lot more useful to people that are consuming those bits, right? Whether you talk in terms of agility, security, self-services, other people have mentioned today. It's about how you deliver that transparency, self-service in a very seamless manner. And that's what really, as a community, a lot of people are focusing on, and I think that's also what's going to drive adoption in this space.
Yeah, so you mentioned data agility. Mm-hmm. What does that mean to you? It's kind of the new buzzword, right? Like we seem to pick one each year and really focus on it.
Yeah, so data agility is interesting. Everyone I talk to has slightly differing opinions on what it might be for them. And when I think about agility, right, there is such a thing also as data gravity. But how do we make data agility, from the data point of view, how do we make it more useful in a variety of different contexts? Whether you talk about test dev purposes, as more mature cloud-native organizations are moving to using CI/CD with data in the pipeline and real data, how do you make that data more agile securely? So maybe you had to have masking along the way, as an example. How do you transparently do disaster recovery, right? We talked about that earlier during the day today too. And how moving that across cloud regions, across hybrid cloud, which is a very big thing for enterprises. We can't just neglect all the people that are still on-prem. 60–70% of workloads are still going to be there for the near foreseeable future. So transparently and seamlessly moving data in these environments, no matter whether they do it at the storage layer, a layer above that, is going to be things to look out for when data agility is concerned.
Yeah.
Yeah, so one key thing of providing meaningful abstractions is to find probably the most common denominator where you can provide the abstraction and then tackle a lot of the services through that abstraction. So what I mean with that is, instead of having different replication approaches for different type of databases, you do it at the block level, because then you grab them all. So what we're trying to do is actually provide these meaningful abstractions, because we're not necessarily too much concerned about the actual storing aspect of it, but more about how do we provide you with a transparent subsystem and abstract your storage just as Kubernetes abstracts the containers for you or the underlying infrastructure. We want to do the same for storage. So you could basically say, I just want a copy on my commodity hardware server, and at the same time I want a copy at my enterprise server. And that makes your system more agile, because if you don't have that flexibility, you cannot move your data, or you cannot move your applications as much because they're tied to the storage system, and that locks you down. And that's the great data gravity aspect of it. And the other thing is that as these cloud native applications start to be, or some say that they, let's say, not rewrite their applications, but they, lipstick them a bit so they're a little bit more cloud native, and then you can separate out stateful components, and then you can have different policies for each of these individual components, and that brings more agility as well. So I think, to sum it up, you need to make sure that your data is as agile as the applications that they serve, and then you're in a good spot, no matter what storage system you use underneath.
Just to go back a little bit, I think I also thought of something that you asked earlier. You said, what are we excited about? Your work on local block storage, I think, is pretty important, and KubeVirt. So I think that's a good thing, as I'm thinking about that. But just to agree with Jeffrey, I think agility for our customers has been, how do I make changes as they want, right? So agility is just saying, I don't want to right size on day one. I want to be able to flexibly make a decision, or change my decision, if you will. And I think one thing that I don't see a lot of people doing very well or easily is Amazon has this great auto-scaling group feature, right? Google has instance groups and so on. And the way they allow you to effortlessly scale out compute, we all like to explain why storage is so much harder. But at the same time, I see customers running in ASGs, or auto-scaling groups. I think they want something like that for their storage. And we all know how to do it in a two-tier model, but I'd like to see it more easily done in a way that works for how they want to do it, in terms of just scaling it out and scaling it in effortlessly, in the sense of they want to change their mind, they want to change their ability to serve applications. And compute's done it very well, and I think we all like to explain why we can't do it in storage, but I think over time we should be able to, right? So I think agility to me is really about doing what compute can do easily. We should be able to do it too.
Right, okay. And so with that, do you feel, Niraj, what do you feel like the role of container attached storage then, in terms of, do you think that provides a better layer for data agility?
I don't know if it does, right? When you go look at even the sponsors of this conference, all the traditional vendors also showing up there too. Mm-hmm. So I think it is about how storage gets used in this environment, right? So yes, it is container attached, but does it need to be purpose-built for containers? I think there might be some use cases, yes, where you have isolated fault domains, but I think some of the legacy stuff working in this environment will do well also. So it really depends on what people are looking for it. And then ultimately, there is the span of things, right? So Eric, thank you for bringing up local storage. Right, the question is, will some of this replication, will some of this auto-scaling come in at the storage layer, or is it going to come in at the application layer? When you go look at things like Cassandra, that really don't like network-attached storage. They want to use local attached.
Right.
So when you go looking at the next generation of databases that might be coming out, is the scaling factor just based on, hey, let me do local storage and replicate at the application? It is more complex. But does that work best for apps, or should we try to do it at the storage layer that gives us more flexibility, but we give something up in there? And therefore, I'd love to hear also what Jeffrey thinks about some of that.
Yeah. So one of the so if you look at local storage, for example, in a node, because it's local, it doesn't mean that you want enterprise class features, whatever that may be, right? Like local data protection, or the ability to create efficient snapshots by using the storage subsystem underneath. And so if you want to do that, how do you do that with your commodity server? So you need something that does that for you, right? But it doesn't necessarily mean that because you use that, you cannot use the traditional vendors like say a NetApp, or combine the two, right? So the composability of what your PV should do is where I think the container space can help. And so for example, a very practical example, if you have a box that talks iSCSI and you have another box that talks NVMe over Fabric, how can I replicate two replicas to these two sides? You need to have something that talks both protocols, right? Okay, how do I do that? Well, you could spin up a container that does that for you, right? So that's a little bit the way I see it.
Could you repeat the question one more time?
Yeah, I was saying, what role do you see container attached storage taking in the Kubernetes landscape?
In the Kubernetes landscape?
Yeah.
I think it's going to be the core thing that makes it really take off, right? I think if I look at Target and all these marquee names doing Kubernetes, a lot of them are still keeping a lot of their heavy workloads on-prem. And that's not necessarily a sign of success, right? So I think Kubernetes is the most important thing right now, and I think it will be for a long, long time. And just being part of it has been great. And I think what will really make it take off is when we can move all workloads in. Because it's really enabling all workloads that's the future. So that would be simply my answer.
Okay, so I'm going to skip my question because perhaps Target is a great example, and there are many others, financial institutions, wanting to keep their data on-prem for security reasons, which is, perfectly legitimate. So what challenges do you think we have right now in terms of the storage offerings we have in Kubernetes related around security?
Yeah, so I'll actually be doing a security talk at the Twistlock event in a couple hours, and so I won't go into the whole talk, but I'll post my deck. But I think it's really becomes about data access, right? So provisioning storage, straightforward. Replication, it's hard, right? But we know how to do replication. I think secure data access and that portability to the first question. I think data access, because microservices go east-west. It's not a north-south problem anymore. And networking understands it, and security understands it. Data's moving east-west. But for some reason, storage hasn't, in my opinion, embraced that. And so I think data access is the challenge, and we can call it data management. But secure data access is what I think is becoming the challenge when it comes to security. And I look at one more thing. Sorry to make the point a little long. Some of the banks have shared with me that they understand that they're no longer going to get their storage from a box. So back to your container attached storage, they know that all their functionality is coming through containers. At the same time, they need a way to securely scan and understand what's inside those containers that are coming in. So I don't think Kubernetes and we as an ecosystem have really formalized what a system container is supposed to do. Mm-hmm. And I think because we don't have a formal notion of system containers, we all have to do, in some ways, kludgy things because that's all we're afforded. And so if we can formalize system containers, understand how to provide that as a well-defined thing to customers, I think that will benefit security as well.
Well, security, that's a smoking gun, I suppose. So containers are inherently not secure to begin with, so making container native storage systems secure is going to be a challenge, right? So, but the good news is that you see a lot of projects popping up, actually at great pace. Very recently, like Firecracker and Intel just released a new VMM subsystem, and QEMU-Lite, all these type of things that basically repurpose the isolation capabilities that VMs provide, but then just for containers. So it's like very, very lightweight isolation. And I think through that we can achieve security, which then becomes an interesting problem for storage. So how do you integrate that with storage? Well, fortunately, there is this thing called VirtIO, which allows you to write things in a ring buffer and just share data between it. And then you can reason about the security. But if the subsystems themselves are not secure, you cannot build something secure on something that is unsecure underneath. So I think that it's not going to be something that the container storage systems can solve by themselves. It has to be full stack.
Great.
So the only other thing I'll add to what people said is when we work through a security solution, we need to think of it as a layered thing. So the storage access, the data management, access APIs. But as software people, we sometimes also forget about the hardware stack. If you look at what Amazon's been at the forefront of, but some now other hardwares are doing, we're also getting hardware-level I/O path security primitives in there. So I think once storage vendors also integrate with some of that, I think we can get a lot more security going all the way up from low-level channels to the application. So it's, and it's not that far off in the future either.
Yeah. Do you feel like some of those conventions need to be adopted into what we use?
I would believe so, yes, and some of that's already happening as this is the ask, right? I think there is a lot of both push versus pull, people wanting the community to grow from the user point of view, developer, vendor point of view. Mm-hmm. So I think there's a happy meeting place in the middle, so I think the answer to that one is yes. Okay.
All right, so last question. What steps do you feel like the community is taking to prevent data lock-in? So if we talk about, instead of data agility, we talk about the data gravity is a real thing. I mean, if you have petabytes of data stored somewhere, I mean, what are we doing as developers to help customers not be locked into one cloud?
You want to go first?
Sure. So I can go first. I think it is very easy to say, let's not do vendor lock-in, especially when storage is concerned. But once you start getting into multi-petabytes, data takes on its own form of gravity. I think we need to be pragmatic about lock-in and figure out when it's okay, when it might not be okay, and do that on a slightly more nuanced basis. And the cloud-native community has the primitives to do that, whether you talk about storage classes, et cetera. So there is already some stuff available that you can leverage for that. But I really do believe that people should try to explore best of breed for where they are at, whether it be in a public cloud on-prem, and see then how to translate between those two in a transparent manner. Right, and have that built into it, because multi-cloud is a thing, hybrid cloud is a thing, right? Cute buzzwords that someone talked about earlier, but this is reality for large companies out there. So thinking about how to be pragmatic about it, but also having a way to move things around depending on your needs is good to work into your architecture as you build out new infrastructure in this space.
So the question was, again, a good answer, but I just forgot the question.
What are we doing to prevent data lock-in in the community?
Well, actually, so we as well, individually probably a lot, but we as a subsystem or ecosystem, or however you want to put it, I don't think we're not doing things to make that easier yet. I think that there is a lot of room to improve. I think that there could be a lot of form of education to a certain extent. So if you have a cloud-native application, let's make sure that people understand that a thing like an object store, whichever object store you use, is a lot more suitable to store, let's say, images of your blog or whatever you're storing, right? And so basically create these two tiers of flash and trash, and from a performance aspect, so that you have your databases running on a different type of storage, and you have your static files hosted somewhere else, and then these storage systems underneath, whichever they are, they then provide the capabilities to do the replication for you, so you don't have to worry about that. And well, you get the quality of service and the probably low latency responses you need for your online transaction processing, for example. So I think that we can do a lot more there, and then finally provide meaningful tools to go from on-prem to the cloud, and not necessarily public cloud, but to your own cloud infrastructure, because you can build your own cloud without going to the cloud, right? So yeah, I think that's one of the things we should be able to do.
So lock-in, I think, is a funny word. So I used to work at a public cloud. We used to always say we're friendly because we're not going to do lock-in. I think if I use a personal example, I'm locked into Spotify, right? Apple Music gives me free months, and I don't use it because I love Spotify's recommendations. So to me, lock-in in this industry really means I don't want to be locked in at the infrastructure level. I don't want it to be petabytes of dumb storage, not that any storage is dumb, but I don't want to be locked in at a point where it's just because of raw compute or raw resources like storage. I'm okay with lock-in if it's higher value, if it's up the stack, if it provides me something that makes me do my business faster, right? Spotify makes me listen to music I want faster, right? So I don't have to go discover. So I just feel like lock-in is one of those words we can overuse, and not that you are, right? But I think we all like to say no lock-in, but if it's valuable, I'll use it. And so am I locked in? Maybe. But I don't want to be locked in a way where it's just because I threw my capacity there once 5 years ago and I can't move it up. That kind of lock-in I don't think anyone wants either. So that one I'm excited about changing.
Yeah, agreed. All right, so I did want to leave some time for questions. Should I run the mic? Who had the question? Here.
So from my perspective, there's two kinds of applications, stateful and stateless applications. And if both of them are Postgres with a cluster, HDFS in a cluster, and if you have those kind of applications which do the replication at layer 7, then I don't see, or I see a few reasons, but in principle, there's no reason for me to use any storage other than local storage. I can think of two reasons. One of them is encryption and rest. The other is maybe RBAC. But other than those, why would you use any replicated storage or storage over the network or things like that? Because No,
I'll take a
those don't need those.
Yeah.
Those Kafkas of the world.
So I'll let these two answer as well. I'll say from my perspective, Kafka and these kinds of real-time systems is the #1 application that uses our technology, right? And there's two fundamental reasons why. One is they're oftentimes shared infrastructure, right? So I'm building a platform, I'm running a piece of infrastructure, and I'm doing it for multiple applications and multiple teams, and I don't want infrastructure that is for single application purpose. So in some ways, you need to take a bunch of commodity resources or public cloud instances and make it run for multiple teams, and at that point, I do need a way to isolate. So I realize that's a little bit of an esoteric answer, but I wanted to explain that there's a shared platform use case where people do want to be able to say that this Kafka gets this quality of service and this application gets a different on a shared piece of infrastructure. The second one is really about throughput, is that oftentimes if you're doing synchronous replication, the benefit here is if you ever have a system go down, a Kafka broker, for example, you don't want to have your throughput drop because you're rebuilding on the fly, because these systems are always on, right? If you're using Kafka, you're probably using it in a pipeline. That pipeline's throughput is extremely essential. And if you're rebuilding a broker in the middle of the night or when something that is supposed to be automated isn't, then your end customers suffer, right? Because these aren't batch offline processing systems. These are real-time systems that are serving in connected use cases, at least the ones I've seen. Now, there are other cases where that might not be true, and then I can understand what you're saying. I just want to give two reasons why we've seen it.
So I would say that the answer is always it depends. For there's some category of applications where you don't need network attached storage. You still need data management primitives on top of that, whether you talk about things like backup, disaster recovery, et cetera, right? So let's separate storage from data management there. So there is that. And then for things like Cassandra, you might not need it, but I would agree even Confluent for Kafka recommends, for example, in AWS to use EBS versus local disk just because of faster recovery. Now, there are sometimes, depending on what your window is and what you can tolerate, maybe you can also dump local storage to an object store and rehydrate that potentially quickly. But right, there are multiple options there. But I think the answer is look at your application, look at what you need, and sometimes fast, cheap local storage might be better for you. Sometimes some form of network attached storage will be the best.
Yeah, I would finally say that fully agree with these two gentlemen. But the other thing is that even if you have local storage and discard the points that they made, then there is still also some room for features that you would like to have, like, for example, having the ability to create local RAID groups to create this form of redundancy such that not your whole Cassandra cluster starts to rebuild if there is just a single disk down or something like that. So the value of having composable storage depends largely on the use case. Rebuilding databases while you're in production because you have a single disk failure, that's not a place you want to be. So if you can avoid it, you probably want. And the other thing is like if you have like real hardware and you want to phase it out, okay, so how do you do that efficiently, right? So server A needs to be replaced by server B, and storage systems typically can help you very well with that to get that done seamlessly and quickly.
All great answers, guys. So I think we only have time for one more question. Anyone? Luis?
It's really short. I'll run back there.
Okay, thank you.
Very short question and very short answers, guys. We want to give this room time for lunch.
I was going to wait to see there's another one, but if not, I'll ask one. What is your opinion on, I've been listening to a lot of your answers, and sometimes it seems to me that as storage vendors, we view the system from bottom up a lot. And I wanted to see, going back to the question on Kubernetes, when the future is how do you see it from the app point of view, from the thousands of users point of view, from a usability point of view for a user, not the IT or the admin point of view?
So my quick short answer on that one is in my day job, everything that I do, I think about the application first, right? Even though I think of myself as an infrastructure person, that is the only sane way, even for operators, to really do things in this environment, and developers, right? How do you manage things? Don't think about volumes, think about the application. Your code's defining it, your code is making new volumes come up, disappear. Think about the application first, be app-centric in everything you do, and that's the only sane way to manage large environments in the cloud-native infrastructure space.
Yeah, so I think it's a very good question, and one of the things that we've done, or at least I should say Evan has made us do, is make sure that we understand the application and the problems that we're solving, and then you'll see that the patterns are fundamentally different, and those differences were translated, at least in our case, in a particular design, such that we have a very granular approach. And we decided, for example, not to build a distributed storage system because we believe that the workloads do not require them anymore in terms of speed and in terms of capacity. So that's how we try to address that, because it is the most important thing eventually.
I feel like that's a leading question, Luis. So there's systems that we've used that are not Kubernetes that lack a lot of things that Kubernetes does well. So Kubernetes does storage class very well. So if you ask, what does an application need to think about? I think applications need a provision, and I think storage classes are poorly used and not often well-defined in environments. And so I get back to the fact that we need to think about it as a shared experience. And if we think about the original intent and design with Kubernetes, right, launching a system in Borg, it's kind of like writing an Android app. It's pretty straightforward, but there's a lot of guardrails. And so I think guardrails is what makes application experiences better, which I just want to throw a counterpoint, that's all.
Can I answer it too, Luis?
Yeah,
all right, so yeah, I mean, I definitely agree with all of those things. I mean, I think we do have a tendency, I mean, honestly, if we're all candid here, that we tend to look at it from the bottom up. But without the applications feeding it, the storage is useless. So I think from a Kubernetes perspective, we've definitely been kind of disjointed from the workflow, and there has to be a point where within Kubernetes it's more natural that we have policies around the application that allow us to utilize the data better. So I fully agree that's the point of view we need to be looking at. So, all right, well, thank you guys for being on the panel. I appreciate it.
Thanks, Erin.
Thanks.